Okay, we are going to be reviewing for exam two. And if you click on exam two, it says password. And I'm not going to give that to you. Gosh. But it's, yeah, I know. So the password will be in the advanced math lab. Or if it's online, it'll go through the honor stuff, but that's not right now. Same as last time, 15 questions. Yeah. And I think it was at least 2 hours. I think we bumped it up a little bit. So I'm gonna, yeah, but I'm just saying this is 2 hours at least. So, anyways, whatever I had said there. So that's good. I have a big list of topics written down that I'm not going to show you. And my job is I'm going to go through the practice quizzes like we normally would, and I'm going to say, "Oh, look at that! Oh, look at that!" And then so we're going to keep going as we go. I would say that these practice quizzes are super awesome as per what we're going to be doing because what I did is I took the practice quizzes and I just dumped them all in at once, and then I started removing questions I didn't like. So I would say 80 something percent of what you see on the practice quizzes are possible in the exams, minus some really difficult ones, of course. So all of this is for sure on there. Okay. I'm wanting to know if there's a way to get like the topic. You know what I mean? Like there's like a hey, it says here match the appropriate whatever. I guess that's close enough. So this is on there for sure. All these kind of questions. There's going to be one graphing question, the very first one. Okay. Do you want me to talk about it a lot, or is that something y'all can just go and try out a little bit again? I mean, if I remember correctly, just guessing right now, it would be on this one. Oh, cool. I think that's correct. Mm, Actually, I think it's C. It is a parabola, but because I have no x, x is what does not matter. So it's all x's. But those little things, right? And what I'm going to say is there's so many to go through. It'd be best if you go and tackle it on your own, kind of like, see, I don't like this, or I do like that, or I'm good with this, I'm not good with that. Find out what you are cool with and what you're not cool with, and we can go from there. But on the exam, I just dumped all these in there. So, like, you'll just get one of these guys. But it's good to study them all, obviously. Okay, whoa. Okay, so that was the last one. Okay, limits are on there for sure, 100%. I think that a lot of these are pretty easy because what I'm going to do is Desmos. I'm going to use some Desmos. Um, because I feel like we should use what we have to best get the answer here. I'm actually going to need a little bit of room. So I'm going to type the original in, and then I'm going to play around with it. Actually, I want a fraction. Go ahead. Hmm. Correct. Or it's defined at the point. Yeah, it's pretty easy. A lot of them, I would, yeah, you have the exact idea. Plug it in. Step one, plug it in. If it does not work, then we can go on to the next step. And I want to find one that doesn't work, but without spending too much time on it. But here in Cal 3, it is okay to just simply plug it in. So if I plugged in a 0 in this, I think I get a 1. I don't know. That's an easy one. I'm looking for something. So secant at 0, it's tangent at 0, but we wouldn't have a 0. So I'm looking for one that won't actually work. And then we can do yeah, here, this one. Here's a good one. Perfect. Okay. So expect a lot of them to just be plug it in, and that's okay. That's what we do here. See, so there's a perfect example of we try and it doesn't work. What do we do? So yes, we approximate it. We get really close. And I'm going to do the 001 kind of business. Here we're going to try 001 maybe. And I mean, it doesn't really matter. I'm just wanting to see where this is going towards. And so if I add a few more zeros to it, you can see that it's not really changing anymore, which is interesting. So that decimal, it might be a real number of some kind. And that's fine. I can't find the fraction from it, and it does want a fraction. So maybe it's a divide by pi thing. I don't know yet, but I am a little bit nervous about it. So what I'd rather do, there's two options. Because we're going to 0, 0, we could try polar mode. I don't think that's going to help. I don't see that as a helpful guide. We could do L'Hopital's, right? So there's what I'm going to do for the L'Hopital stuff, and I'm just trying to keep this as quick as possible. I can set one of them equal to 0 and then just go and find the other one. If I set x equal to 0, we're lost. So that's the one I actually want to do the derivative stuff on. So I'm going to set y equal to 0 and then like do something over here. I don't know. That's the idea. I'm gonna do something with my x instead. So I'm gonna set y equal to 0 right now because I know that's for sure. And so then I would have e to the y. That would be or e to the 0 is a 1. Sine of this guy, and then I have this guy. Oh yeah, I can tell what we're gonna do here. And of course, you don't need the 1, so I'll just get rid of it here. What can I do with this minus right here? Do you remember one of those rules? Can I get rid of it, or can I pull it out? Which one? Yes. Even and odd. Yeah, so this is an odd. Yeah, this is odd, so you can pull it out. It's kind of like doing this, and then wouldn't it actually be this guy? Rather than even would just get rid of it, if that makes sense. So this is an odd. I could pull it out, and two negatives will make a positive. It just makes it a little bit better, when we're doing this math here in a second. So L'Hopital's, that's an x, and that's an arrow, and that's a 0. That was the worst thing ever. So anyways, limit, derivative of sine is a cosine. I'm going to leave the inside alone. Take derivative of the inside is just a 3. So I'm going to put a 3 in the front. In the bottom, just a 5. When I plug a 0 in now, all I'm left with is this stuff. I'm nervous. I'm nervous because. Go ahead. Oh yeah. But see, this is not 3/5 in my mind. Oh, you know what it is? I wonder if it's degree radian mode. Oh, look at that! Degree radian mode. Oh, okay. Zoom back out for a second. I was getting at nonsense, right? But it was the same nonsense. When I went to radian mode, this was clear. Like, I don't have to guess about that. I can go, well, actually, 59999, wouldn't that just be 0.6? So I could have just seen that. Wow. But we did it anyways. Yeah. So the plug it in, the 0.001 thing actually was good. It would have been fine. I just forgot about radian mode. So yeah, those silly little things. Yeah, this one is the same kind of style. Again, just try to plug it in. I'm looking for the next one because there's something like it here. Same thing. Not worried about it. Nope. Something new, something different coming up. I think I removed that one. Okay. Why? It's not that hard. Well, but it's just a lot of words. Yeah. And I don't think I kept it. This is the one. Yeah, the polar. So the polar is the next thing that could be there. Let me again be silly and just try to do it the old school way. This is definitely not the right way to do it holistically, but we're on exam. I want to just see if I can get an answer real quick. So when I plug in 0, 0, obviously it's not going to work. But if I tried something like this, we go negative positive. You see that something's going on here. If I change that to a negative, I would do something like this. What if I go like this? You see what's going on? What is this answer right here? Round to 3 decimals. Exactly. Right? And even when we have the exact same numbers, I mean, well, I had it earlier when they were like these. Yeah, see? So I would assume a 0 for this. Get rid of this bar. Give me a second here. This is just dumb bar. Blah, blah, blah. Bar. Get the bar out of here. Anyways, so my thoughts are 0. Okay. Now we could do this the polar method. Let me just do another one with polar. Yeah, this one's great. I just want to do it correctly for once, I guess. So I feel like I'm a good teacher. So I've got r squared is equal to x squared plus y squared. And what I'm wanting to do is say the limit as r goes to 0 of this stuff. So then I would have cosine. And the top. Okay, well in the bottom I got this. Go ahead, top.
The top, would that be r cubed cosine cubed?
Minus r cubed sine cubed. So then these r's are going to cancel. The r's are going to cancel. Sorry, I'm just being a dork for a minute. So I got a single r. Everything in the bottom's gone. Essentially, it's just cosine cubed minus sine cubed. Am I right? And I'm wanting the r to go to 0. I don't care what that stuff is. I'm going that to 0. So then what's cosine of 0? Perfect. So I did it the long way once. Now that you can see, I did it. Good with this? Good idea? Oh, this stuff. X is equal to r cosine, and y is equal to r sine. I just didn't write them up. I should have, though. Yeah.
When we solve it down, when we get cosine 1, like the equals, because it's all the stuff that you worked with your cosine and stuff like that is inside. We plug in the limit of 0, 0, that being cosine 1.
Oh, no. Because if I plug in 0, 0, I would get 0 in the bottom. Right?
Right. Well, I was thinking when you plug it in, you're plugging it on the inside with the thetas. Oh, there's a singular r. Okay, I missed that.
Yeah, just
The rest
r.
of that cancels out, just r.
Exactly. Because it's 0. 0 times anything is 0.
Right.
Cosine of 0 is a 1. Yep.
I don't know why I was thinking plugging in theta instead of r. That's where I got me.
Well, and so in polar mode, they're saying that theta is anything. Anything. Rather, I would say everything. But here it doesn't matter.
Right.
Okay. So yeah, polar limits are definitely on there. That's a yes. Okay, this is a yes, and it's almost too easy, but I have to have something there, right? So partial derivatives, not too bad here. So yeah, I call them first partials. Then there's going to be other ones that are kind of similar, but are y'all okay just taking a derivative? I mean, I could do it if you want me to.
I don't know.
Okay then, okay. So derivative in terms of x, the 9 comes down.
9 times 6 x.
Okay.
And then nothing else. Negative 8y.
Okay. Well, yeah, I'm not going to check it. Y'all know y'all are right. So let's go through and just look to see if there's something that stands out, more than another. Yeah, like all this is not a big deal. Like we've said many times, you can always take a derivative. The only time that it's a little bit more difficult, like that's not hard. I know that looks like a lot, but it's not that bad. It's just quotient rule. But very doable, yes. Very doable.
The last question, please.
This one?
Yeah, stuff with the. That's kind of the ones where I'm a little bit more fuzzy. But imagine actually looking at this, that would just be
The same thing. Yeah, there's like no change at all because there's a 1 in the front of both your x and the y. Like that.
I also thought it said like x times y because that stuff was the ones
Oh yeah, no, that would definitely do a little different. But so far, derivative ln went over stuff.
Yeah.
Done that. This is actually, I don't think I put that on there because not because I don't like it, but because it would be unfair of you to get a simple one and someone else gets a hard one. So I'm trying to equalize it. So I don't think I put that on there just because there's too many boxes. That would be unfair to one person, not to the other. So no, don't worry about this. I love them. I think they're great. I don't think there's enough of them for me to merit it. Right, right. Well, yeah, yeah. I just don't think I have that. This one, I don't think so. I have a different kind. It's similar to this. Um, though I love these problems. I don't know why I didn't include them. Hold on. This is something that's on there. Yes. Okay. So I feel like I skipped something. Let me go back because I know where I am now. I don't know if it's this one or a different one, but yeah, I'm gonna assume it's this stuff. Arctangent? I don't think I put that on there. I'm just trying to remember. I just did this a couple minutes ago. Okay, it's not that. I don't think it's that guy. But I think it might be this one. It might be called something differently that I have written down, but it's not that bad. You can do it two different ways. You could do it that's right. It's called implicit stuff. Is the word implicit anywhere? Whatever. Blah blah blah. Let's just talk about it for a minute, just in case. I can't remember if it's the exact or if it's pretty close. But there is something in between those two, and this fits the bill. So what I would do personally is I would just plug them in and then just take a big derivative. I mean that's super easy to do. We all know how to take a derivative, and then you just plug it in, right? That's not hard, not hard at all. If you want to go down the other road, that's fine. But my first inclination is just plug it in. Now I know that this looks a little bad, but my x when I plug it in, e and ln are going to cancel, so it's almost like better to just plug it in. The arctangent, when you plug it in here, you'll have arctangent. I don't know if I included an arctangent though. I don't remember seeing it because then you'd have to take a derivative of arctan, and I can't remember that off the top of my head. Oh, great! It's 1 over x squared plus 1.
X squared plus a squared.
Right. Right. Exactly. So I don't know if I did that one. Again, I would just plug them all in at once for the exam. Now this is definitely on there. I mean, unless y'all want me to do it, I can. Okay. You want me to do this one or the arctan? I can't. Yeah, can't remember if I kept the arctan or not. But let's do it nonetheless. If you want to, I'm fine with that. So 8 times y. So that's arctan of t. And then I have e to the x. Again, those cancel, leaving just t squared plus 1. Minus ln of z. Well, e and ln cancel, so it's just this guy. I mean, it's almost like way easy to just plug him in, you know? And then I just need a derivative of this big thing. So this is definitely product rule. This is that FG business. And so then we got F prime G plus FG prime. Right? So 8 derivative of arctan is this stuff here, I believe. Plus the 8 still in the front. Leave this one alone. Derivative of this guy, 2t. And then all of this stuff still minus the 1. I'm going to scroll back. Sorry. There you go. Whoa. That's kind of nice. Makes me feel like I'm actually doing something correctly. 16t times. Ooh, do you think they'll take it? That'd be pretty cool. I would take it.
I think you also forgot the 2t on that one as well.
I included it with the 8.
Oh, okay.
And that's not a dot product though. It kind of looks funny like that. Yeah, G prime. This is my G. So I did prime.
Oh, sorry. One of those is an F, right? The derivative of G.
Derivative. Yeah, this is F prime G, and this is F and then G prime. Yep. I guess my F prime's a little off, sorry. Yeah, this. There we go. You got it. Plugging in a 1, we get arctan of 1. Y'all know arctan of 1. Good, good. See, y'all got this. Sorry. So it says an exact answer. I'm gonna definitely have to do more than this. Close enough. Close enough. What is it? 4 pi minus 7 or plus 7?
7, 4 pi,
Yeah. Okay. Cool though. Again, I'm not 100% on that one because what the title is sometimes different than what they talk about. I wrote down different implicit, and again, I can't remember 100%, but it's close. Anyways, same kind of deal here. I plug it in all at once and take a derivative. So this is definitely on there for sure because it's just a continuation. It's the same stuff. It's just now that you plug in a point. So not too bad. Derivative, easy. Looking for some hard stuff. Or if you're worried, I'm not worried about these guys. So the only difference is you're plugging in some numbers. Oh, wait, right there. See that guy? No. No. That's not on there. No. If you see that on there, you get a free point, okay? Because it's not supposed to be on there. I don't know what the derivative of arc cotangent is. Can we derive it? Sure, but it's not the point here. I'm not trying to relearn trig identities, you know? So, no, that's a no. That's a no. Exactly. Gradients, for sure, 100% are on there. But we just did this. There's just 3 derivatives, right? So, again, unless you want me to do it, I can. You just tell me. Okay, whoa. What about that guy? What's the derivative of arc sine? He's not on there.
Okay.
See, I mean, if you can't immediately know that formula, it's not a good thing. I don't like that because you don't have formulas like that. You don't have enough room for all that stuff. So linearization's on there. Again, this is the gradient. I want to do one, but the gradient with the points plugged in kind of thing. So like that one's too easy. Let's do a little bit harder one. So yeah, linearization for sure is on there. Let's do it. So this thing, I'm going to do derivative in terms of x, and then derivative in terms of y. So the 2 comes down, leave everything else alone. Derivative in terms of x would be yep. So that's 6 in the front, blah, blah, blah. I don't think we need to do anything else with that. Rather, what I would do is plug in our points. So notice that we got 0, 0. So I want to plug in 0. Because, 0, 0, I guess, because it's x and y. And we get...
Wouldn't that be 12?
Oh, so there's a 2 in there. You're right. Sorry. 2 times 6 is 12. Yes. Good thing you're here. Good thing y'all are here. Cooperative exams, right? Yay. Again, 0, 0. So that would be an 8 in this case. So these are kind of like my slopes. So I've got 12x plus 8y, and well, actually, I think that's the answer, but let me just verify what I'm going to do here. It's technically x minus 0 in this particular case.
Don't you also have to add
Oh, plus the original. Yes. plus F0 essentially.
Yeah, which in this case would just be 4.
Right. When I plug in a 0 and 0, I get this guy. So yeah, that would be a 4. Right. So like that little thing I had forgotten. I had forgotten about the add thing at the end. Good thing I have that written down on my note card. Right. Linearization. It's that Black Rifle coffee that Christina gave us. It is so smooth. If y'all don't drink, angry. So you came home broken. Okay, sorry. So I plugged into the original. It's kind of like the Y-intercept in a way. So you have to plug 0 into your original, and you would get whatever. So to be able to do the next one, you would just plug in a 1 and a 3 everywhere. Same process. Cool.
Is the percent error on this one as well?
Percent error?
I don't remember if it was percent error, but it was something error. Yeah. Like where you're given a range of between 0 and 0.1, the error for x, and then you have to plug it in.
I don't know.
Don't know.
I mean, I'm
It was also associated with the linearization stuff.
gonna be adding points, obviously. I don't know. It says exact answer, so I would imagine just exact stuff. Same process here. Is that okay though?
Yeah.
Just derivatives, right? Nothing new here. This is on there. Mins, maxes, and saddle points. So every one of them that I saw was like this, where there's a whole ton of polynomial looking stuff. I don't think there was much variation, honestly. So yeah, it's just this kind of style. Y'all want me to do this one?
Yes.
Okay, good. I can do another one even after this. What I'm thinking, like, what I'm, we're doing the review here. Today, I'm pointing out stuff that we're gonna definitely see, and then, the next time, when I'm done, y'all tell me more specifically. Go back and do this. Go help me do that. You know what I mean? So I need to have x or f sub x and f sub y both equal to 0 at the same time. So then I got 2x plus y plus 5. And then I've got 2y plus x minus 5. I feel like I need to just put it into a matrix and solve. But we can do this either way. I know, right? Exactly. Thank you for reminding me. I was just tempted for a minute. So I plug it back in. And again, you're only getting one of these. I know there's like, oh man, there's so many of them, but you're only getting one on the exam. It's just, which one do you get? Minus 3, 15. So I'm going to say negative 15. So y equals 5. I can plug that back in. 10, negative 10 plus 5. So negative 5. So my answer is definitely negative 5, 5. But now, is it a min, max, or saddle point? Ooh, wait, you lost me at half-to.
You have to take the second derivative to figure out if it is a local min, max, or saddle. Or are you talking about something else?
Yeah. You know what? That is perfect for the recording. Because that's the true answer. That is the right thing to do. You should go and do second derivative tests that you wrote down on your note card and stuff like that. But in the event that you don't care, you should. But if you don't, then you just plug it in to your minimum and you're good. The reason why is because this is a paraboloid. Yeah, think of it kind of like a parabola, but it's in 3D now because it has a y. So yeah, what do we have right there as a minimum? Why do I know that? It's because everything here is positive, right? I guess you can complete the square and stuff, but the main key things is the squares are both positive.
Right. So that means they're both going to be going upwards in
Yeah.
their direct respective directions.
Yes, exactly. That's exactly right. I don't know where that's going up and stuff, but it is going up. And therefore minimum. And so I can cut out a lot of that stuff. I have to plug them back in, so I have to plug it all in, and I'm just going to use Desmos for that. I do want to finish it up so that I feel like I did it, but ultimately, this is not the hard part. It's just a time waster at this point. Cool. Oh, did I? Oh, this guy? Oh yeah, minimum. Oh, why? Why it was it? Oh, because it's a parabola, paraboloid. See how these are both positive? So if you just look at this fact right here, you got a parabola, and then if you looked here, it's also a parabola, and they're both got minimum stuff. So it's a minimum. Now, if one was going up and one was going down, that's like a saddle, right? So that's some kind of saddle something going on. Or if they're both going down, then it's going to be a maximum, right? So I just look at it. Now, here's a small thing that could go wrong is that, yeah, we found a minimum. That's awesome, right? Great. So I got it. And I forgot to click this and this. Okay. Now, I would add 100% points because obviously that's just forgetting to click it. You got the right answer, but you do need to make sure it says not this, not that. Good? If you can. Of course, I got your back. Cool. Good though? Good? Are you okay with that? Okay. It makes it easier if you want to look at these problems we have here and go to Desmos 3D just before the test, kind of like see what they look like and, oh, I understand. Like this guy right here. What would I say now? Min, max, or saddle? Because they're both negative. So this one's going down and that one's going down. So they both going down means we're going to find probably one point that's at the highest.
So we can figure out if it's a maximum or minimum depending on
The squares.
power in the.
Yes.
Okay.
Yeah. We called it leading coefficient test and behavior, but now in 3D. So again, I know it's a little longer. What's up?
Is it possible to see one where it's like x to the third?
Yeah, same thing. Cubes, or so odd powers, they keep going, and even might be. That's where I'm kind of like, yeah.
That's where you take the second.
I might have to. Like on this guy in particular, he's making me nervous, right? So I got a parabola, but then at the same time, what's going on with that y? You know what I mean? This is a perfect candidate for. It's not too bad. Let's go and try it and see what we can get. We might end up getting something good. Might just be going down a terrible path, but whatever. Let me just rewrite this here. So 4y minus 3. Okay. So f sub x. Boom, boom. No, I'm just going to do it. Sorry, bro.
Sorry, the way you phrase sometimes it seems like you're asking a question.
I know. I'm sorry. I can solve for x pretty easily. And then I can plug that in directly. So then I've got negative 8 plus y plus 3 is equal to 0. So that would be a negative 5 on this side, so a positive 5. What I did end up with is a single point, okay? That single point that's going to be the answer. So it's only going to go in one place. Now, I'm trying to remember these formulas. I don't have one written down, so you're going to like kind of help me a little bit, right?
That is correct.
But that's not the part that's hard. It's the this thing or the that thing, you know. I think that it's less and it no. I think it's more and it'll be a min or a max. I think. We're gonna go and find out, okay? That's something that's the stuff that you need to write down for sure. So let's do some more math. XX 2 YY 0 XY so 1. And so then we got 2 times 0 minus 1 squared. 2 minus 1 is 1, like it's in positive, greater than 0. So does that mean it's a min or a max? Did you look that up?
Wouldn't that be -1? Or like it wouldn't equal 1 because it's times 0, so therefore the 2 cancel out.
Oh, wow, how stupid of me. Look at this. Has this ever happened to you on an exam?
Several times.
Man, that makes me feel really bad. Dang. Yeah, that was a bad thing. So does that mean it's a saddle? I'm not going any further till I know.
With this, if that test is like if 0 is greater than the number you get, it's always a saddle. If it's the number you get is greater than 0, it's a min or a maximum.
So is this a saddle or not?
This is a saddle.
Okay.
I'm trying to figure that out.
Oh, well, if it's a min or a max, then you're looking at XX, and if it's less than 0, it's a maximum, I believe, because it's always backwards. And if XX is greater than 0, then it's a minimum. But yeah, that's just if you're in that zone. I think I'm just relying on y'all. So y'all say it's a saddle. I'm fine with that. Oh no, where must have.
And to figure out if it's a min or maximum, if you take the second derivative of x, if the second derivative is greater than 0, it's a maximum. If
Oh,
it's less than, it's a minimum.
What? I flipped them? You're saying greater than 0, it's a maximum?
Yes.
Are you sure?
I have it right here.
All right, fine. I trust you. Anyways, so not, and then the saddle I would say is at those points. -4, comma, what did we have?
5.
5. Yeah. Now they don't ask for how high on the saddle, so that's it. We're done.
Because it's kind of hard to like definitively say that is how high because it's actually moving in a lot of different directions.
It's not as meaningful. It's true because it's not going up or down. It's going both. Good. So you write the formulas down and we're happy. Everyone's happy. Okay. Same stuff. Min, max, or saddle.
No, maximum.
Maximum. Good. Good. This guy.
That would be a minimum.
Minimum. Yes. This minus just means it's shifted into like quadrant or octet 1, I suppose. Yep. Minimum yet again. See, so this is easy stuff. Minimum again. Probably.
Literally the exact same.
Yeah, sure.
That one might be a saddle.
That's a saddle. Oh yeah, that's a saddle for sure. Yep. All good there. Uh-oh. That would be I have to test it. But I mean, it's not that bad. Looks pretty easy. Yeah, it's just, yeah, this guy, I'm thinking saddle. But I'm thinking. I just said I'm thinking, okay? I don't want to.
Actually, it could still be a min or a maximum
Maybe.
because it technically does curve down and slightly comes up and then back down.
Not in this case, I'm thinking, because it's too simplistic for that. It could, like, generally S cubes would have a max and a min, so you might get multiple answers. But I think that one you're not. I don't know. I would have to do the math. Now, this guy, I would say you probably get multiple answers. Because you got a cube, you got some squares going on. Yeah. I can do it if you want, or I can keep moving and doing topics. Okay. Yeah. I mean, I'm assuming that. I mean, I'm not. Oh yeah. Well, I mean, they are all troubling.
I remember this section, the homework question too. Completely kept kicking my butt over and over again, and it was one of the simplest problems too.
Happens to me too. And yeah, forgive me for not asking. I'm just doing it.
That's 4xy, right?
4xy at the end. All right, Mr. Cursive.
Dude, is now a good time? He's gonna be looking at yours. He can say, "Oh, well, I don't understand your handwriting, so therefore."
Ooh, that's mean. So y is equal to negative x, and I toss that in right there, I guess. So 28x plus 4 times negative x, and then minus the 6x squared. I'm trying to combine these together. That's why I did it in weird order. Okay. Factor out an x. See, multiple answers. We get 0, and we get 4. And then I go back, and I'm going to look at each one of these individually. Oh, right there, negative. So then we got a y equals 0 and a y equals a negative 4. So now we got our answers. Now they have to go into whatever boxes. And they could both be, well, thinking of it, you can't have two maximums. You'd have to have a minimum in there to be able to have them. So here's an idea. If you don't want to go through the long process, I have a Desmos method out of it. It's not always happy, but man, that is good coffee. Like, whoa. Okay. Yes. I'm going to plug them in directly and see. Actually, that's a very good point. Not just only what I have, but also around it. That's a very good point, though. I didn't think about that. Yeah. Oh, I like that probe. Yeah. So this one is at 0. Let me just go ahead and if it's a min or a max, you're gonna have to have it anyways. So what we're doing, I think, is still efficient, just in case. Because if it's a saddle, then whatever. You just wasted a second. But if it's a min or a max, you have to do this anyways. So because like that's part of the answer, right? So we got one that's higher than the other. Now you're thinking, well, that's the maximum. Maybe. Could be a saddle. Yeah. So let's like you said, probe around them. Again, this is not the best method, but it's okay. So let's do something like that. And you can see that this is higher. Now, definitely got to try some negatives. Still higher. Still higher. Still higher. So all my combinations around it are higher than where that guy was. Minimum. So this is a minimum in my opinion. If I got a negative for one of those answers, that would be a saddle for sure. I mean, this is not great. I should be doing more math, but I'm just showing you an alternate method. Okay, so 64. Let's do the probe thingy around it and just want to see. So this is smaller on this side, bigger, bigger, bigger. So then only one of them was smaller. I'm thinking a saddle. Yeah, and this is again me guessing. Yeah. That's just a guess. Of course, I'm going to like test it all out here in about 10 minutes, maybe 5 minutes. Okay, so 0, 0, min, and then the 4, negative 4 is a saddle. That's one to go. So there's no maximums. Go ahead.
Aren't we supposed to get technically 4 points to test with it since we're given x is equal 4, 0,
I plugged them in. So I use this formula to plug them in. I only had the two answers from right here.
Right. Yeah, we didn't have.
So I have two answers for X. And I just found Y accordingly.
If you have y equals x equals 4, you're not going to get the derivatives.
Right. Okay, let's keep looking around a little bit. Cubes, probably expecting some saddle stuff in there. Maybe a min and a max, depending. This guy is interesting. So if you like kind of zoom out with this picture here, what if I had 1 over x squared plus 1, let's just say. This is kind of more like the basic one. Well, even with the plus 1, I think that's just shifting it. So it's kind of like this here. So if I was to get an answer, oh, well, the plus 1 makes it so that it's not undefined anymore. That's right. This one does like a hump. So then you'll probably get a maximum out of that. I'm thinking a hump. I'm thinking well, but here's an interesting thing. If I plug 0 in, I get a negative, right? But then if I plug in a combination, could I get a 3 out of this? Like square root 3, square root 3 or something weird? So I could blow it up at some point. I mean, again, we have the formulas. It's not too bad. So my method is breaking down a tiny bit, but that's fine. Okay, let me look at what's going on here. The next thing, Lagrange. Now, hold on. Don't discount these guys. Yep. I think that this is qualified as min max extrema stuff. This one is not on the exam. Not, I can tell you, because it's a very simple answer. It's 6. Like, that's too easy. Okay, I know these problems, and so if it's silly, then it's not good. But this one is on there. These application type of problems are on there. This one not. This one's not on there because it's just all the same answers. Dumb. Because then it's not fair. If you have a hard one, someone else has an easy one, then you don't like me. So everyone gets hard ones. This one too. That one's on there. Again, though, think of it like the engineering stuff. You're most likely going to get it wrong just because it's strange and weird. But do some work on it in the workbook, and it shows the progress, the methods, the steps. And like if you took a wrong turn at some point and you kept going down that road, well, I mean, did you at least keep driving the right speed limit? You know what I mean? If that was the correct way, I can't just say, oh, disqualified because you didn't meet the target. And that's kind of the point here, you know. So I want to go through some of these, I really do, but we don't have the time. Don't focus on the easy ones because they're not there. But each one of these has a separate formula. Okay, yeah, same style here. All of that's great. It's good stuff. I don't like that one. It's too easy. When there are like no differences in X and Y, it just makes it so easy. It's silly. I think I'm going to submit it. This one is definitely on there. Is this the ant problem? There's another one with the ant, where the ant's walking around, the temperature, blah blah blah. That's that ant problem. Oh, that's the end. Okay, I don't know where the ant problem is. Maybe that was it right there or something. Planet ant something. But yeah, that's still on there. That's for sure on there. Okay, I want to submit. I just want to see what we're going. I can come back and do these next time. You could specify, hey, can you do the planet problem? And I could do the planet problem. But my goal again is I want to just at least get. I want to get like through it so you could see what is on there. Okay, let's see what I got wrong. A lot. So let's go check it out. I just didn't click, but we got that one right. Yay. Okay, good. Uh-oh. Aw, didn't do it. Good. Everything we did was good. Look at that. Okay, so we have 4 minutes. I kind of want to keep going. But we'll come back to those application type problems next time or the time after, depending. But since we got 5 minutes, 4 minutes, whatever, I still want to go through one more practice quiz, at least a little bit. Is that cool? I mean, where y'all have to go anyways, right? To work, and class, and anyways. Let me make sure I'm at the right place here. Yes, good. Yeah, this is on there. Easy double integrals. Easy double integrals. Iterated integral, that just means it's like you plug it in, okay? Simple stuff, simple stuff, simple stuff. All this is a yes. You got to have something simple on there too. That one is on there. It's not hard. The e's and the ln's cancel. Easy, easy. What? I can do it right now. I mean, again, yeah. Let's do it. Since we have some time. So first off, I'm integrating in terms of y, which means I'm dividing by that 3. So I get a 1/3 and leave everything else alone. And I'm going from 1 to ln3. I plug that in for y. So let me make sure I'm doing this right. I want to be careful here. Minus, and I do the whole thing again, but now I plug in a 1. Now I know that looks chunky and clunky, but my next derivative is going to be pretty simple too. Or my next integral, sorry, my next integral. So integrate here with my x, I go with the 4th, so now it's going to be a 12. We'll cancel in a minute. We'll get there in a minute, okay? I'm doing it super, super chunky clunky. That's a 12. What was I thinking? Okay, 12. From 1, no, it's 0 now. 0 to ln2. And I plug those guys in. Now, I want to simplify a tiny bit before I go too far. No, I don't. No, don't do it. Go on and hate me all you like, okay? Everybody does their own math. Plug in the ln2. Okay, so that was the first one. Minus, now I plug in a 0. Chad, you're driving me insane. Okay, that one's not too bad. So this chunk minus that chunk. Because you're adding in the power, it means you're multiplying your bases. Everyone's got a 1/12, so I'll just do it in the front. So I'm multiplying the bases. So this is E4 ln of 2 times E3 ln of 3. ln. And then over here, same thing. I've got E4 ln of 2 e to the 3 minus this guy here, E3 ln of 3. And then 2 negatives make a positive, E cubed. The powers will come up. Wherever you have a power, it comes up. And then my E and ln will cancel. So this is 2 to the 4th power. 16. This is 3 cubed. 27. This is 2 to the 4th power. 16. This is just e to the cube. There's nothing to do about that. So that's again 27, and then e cubed. Essentially, we're going to combine like terms and get an answer. I guess I could submit it since we're doing all this stuff. Will it take all that craziness? What do you think?
If it does, I think it easier, but I don't know if it will.
We're going to try. I'm going to submit on this. see if I get it right since we're out of time. Click. Oh, submit button's up there. Silly me. Ha 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 ha! Look at that. They accepted that silly business here. Oh, they don't show what the real answer is. They just say, yeah, you're fine. Okay, cool. We did it. Yay. But does that make sense? Okay. Cool, cool. All right, we're done with the recording. We'll pick up where we left off and keep on cruising, okay? Thank you, guys.